Hey Geometry, we are in Unit 2, Lesson 2. We're still talking about congruent parts. And let's talk about this. My dog is now joining me. Sammy, go lay down. Come on. Sorry. I'm outside because, as you may have heard in Lesson 1, I have some family members that are playing video games in the house, and they're really, really loud. Alright, so each pair of figures is congruent. Decide whether each congruence statement is true or false. Get my draw out here, pen. We see that triangle ABC is congruent to triangle FED. That means angle A is congruent to F, angle B is congruent to E, angle C is congruent to D. Also, get my pen working. Side AB should be congruent to side FE. AB, FE. Yep, those look to be the same length. Side BC is congruent to ED, BC, ED. Yep. And then beginning and end, AC, FD, AC, FD. Okay, so that seems to be a true statement. Yep. True. Now, quadrilateral, PZJM. PZJM is congruent to L, nope. If I look, P is labeled first, which is right here, so B should be labeled first, okay? And B is not labeled first. So they have to be in the correct order, because remember we talked about corresponding parts of congruent triangles, or in this case quadrilaterals, are congruent. Z is second, so we go P up to Z, which is the short side. It would have to be B to Y. So we can say that PZJM is congruent to, gotta move this out of the way, PZJM would be BYXL. That would be the true. This one's true. And this is false. Triangle JKL is congruent to QRS. So JL is the short side. It's first and last. So QS would be the short side, and QS is not the short side. So JK is right here. That should match with QR, which is right there, which is not true. Or we could say false, like we did in the first one. People in my backyard, sorry if you hear that. If we wanted to say it true, I could say that triangle JKL is congruent to, let's see, JKL is SQR, JKL, SQR, yep. Oops, triangle SQR. The frogs are coming out too. All right. Pentagon ABCD is congruent to pentagon PQRST. ABCDE PQRST. That looks like a regular pentagon to me. Regular meaning that all sides and angles are congruent. And that one is true. Yep, true, false, false, true. Awesome. Moving on. So which triangles are congruent? Here are three triangles. Triangle PQR is congruent to which triangle? And explain your reasoning. So here I have 5.9, 4.3, and one angle. So this angle is not included in between the two sides. I can say that because angle C is included in between the two measured sides. So angle 46.6 is next to the 5.9 but not included. 46.6 is next to the 5.9 but not included. So it looks like this one might be correct. Let's check this one though. 46.6 is next to the 5.9 but not included. Alright, so that wasn't a good test. Let's see if we can whittle it down just a little bit further. I'm going to go 4.3, 5.9, 46.6. 4.3, 5.9, 46.6. 4.3, 5.9, 46.6. So it could be all of them. Okay, it could be. If I look at my unmeasured side and I compare it to my unmeasured side, those don't look to be the same length, do they? So I'm thinking none of them. Okay, and there's actually a theorem that will prove it. The book seems to think that it is MLN. Let's try to figure out why. So if we had our compass with us, we could measure side ML and show ML is congruent to AE. But because we don't, it makes it a little bit more difficult, doesn't it? Yeah. Okay. Question 2. Show a sequence of rigid motions that takes PQR to that triangle. Draw each step of the transformation. So first, I'm going to get out my red pen. I'm going to take angle A and draw a directed line segment and match that up with M. So that is, translate triangle. Oh, I'm on the wrong triangle. Sorry, that was tragic. So this would be not AE, PQ, PR. Whoops. All right, so let's translate this one. Did you catch that and you were wondering what I was doing? Translate triangle PQR via directed line segment PM, and then, so that would mean it would look sort of like this. It's going to get a little messy, isn't it? So that would be P prime, R prime, Q prime. That would be 4.3. My air conditioning is now kicking on. 5.9. And the angle. Now I'd like to rotate. Counterclockwise. On center, I don't know why I did B. P prime until R prime coincides with, it doesn't like it when I come off the page, does it? With L, okay? So I'm rotating it this way, and I'll just erase that. It'll be all right. Oh, didn't want to erase all that. But we just made R prime, it should be double prime now. And this was still P prime, it hasn't moved. And this was 4.3, and that was 5.9. And now, I'm going to move that, I'm going to reflect. Reflect over LM. And that just means that Q will coincide with N. Q double prime will coincide with N. And that means that that once we transform PQR onto LMN, we'll show that all the corresponding parts are congruent. Okay, that's the goal there. Explain why there can't be rigid motion from PQR to the other triangle. Well, if I transform this way, that means that would be 5.9, that would be 4.3. And this is my angle. So that wouldn't work. Let's see if I can try again. If I took P all the way to A, it still wouldn't be in the right orientation. There's no way I could get it into the right orientation. Very messy. Okay, are these parts congruent? So triangle ABD, and is a rotation of triangle CBD around point E 180 degrees. Okay, we know that because we've actually done that. We just did that in the last lesson, didn't we? Is angle ABD congruent to angle CBD? ABD, CBD. No. Oops, I'm still in highlighter. They were asking if angle ABD, which is this one, is congruent to CBD, this one. Okay, no, because when we took the yellow triangle and rotated 180 degrees, ABD corresponds with BDC. Okay, because of that 180 degree rotation. Okay, we took point B corresponds with point D down there. Polygon HIJKL is a reflection and translation of GFONM. So HIJKL, highlighter. See if I can do a better job. Okay, yellow is a reflection and translation of the other one, which I can do in pink. So the pre-image is pink. If I do it in segments, then I can erase in segments. So it looks like is segment KJ, which is this one, congruent to segment NM? This one. No. If so, explain your reasoning. Well, I rotated this, no, I reflected this and then I translated it. So that means that KJ corresponds with ON. Okay? Not that one. Okay, because they're corresponding. It's a reflection and then a translation, so they're corresponding. And now quadrilateral PQRS, I don't see that one. PQRS is a rotation of, let's draw it. I'm just going to draw a basic PQRS is a rotation of polygon VZW or YW. I think we're missing something here. Even without a diagram. Okay, so is a rotation, so everything should be in the same order. PQR is angle, nope, is angle QRS congruent to angle ZYW. Actually, yes, we can just, even without a diagram, we can just look at the letters. Analyze the letters and their order. Okay, so those are just with how they're named, okay? That's the letters. So QRS corresponds to ZYW. Corresponding angles in a transformed figure are congruent. So angle Q is congruent to angle Z. Angle R is congruent to angle Y. Angle S is congruent to angle W. Therefore, those pieces will be congruent. Cool. Let's see. What are we doing with this? So here I have a quadrilateral. Display the congruent statement. A, B, C, D is congruent to J, K, L, M. Okay, that means that segment AB is congruent to segment JK, BC is congruent to KL, CD is congruent to LM. I'm just looking at the letters. I'm not even looking at the drawing. And then beginning and end, AD is congruent to JK. Now let's check it out. AB, congruent to L to JK. Nope. What in the world? So just the letters, and then trying to look at the drawing. Nope. So that congruent statement is false if I compare it to the drawing. Okay, BC, let's change colors, is up here. That should be congruent to KL. Okay, nope. Okay, so that is in the wrong order. I can say that A, B, C, D is congruent to L, M, J, K. Okay, that's true because they're in the correct order. If I look at it, A, B, C, D, L, M, J, K. All right, that's the correct order. Cool. All done for lesson 2. Good job.